My name is Eric Petersen. I'm with RH Borden, and I would really like to be in your office, but as we can't meet together, we're going to meet virtually through this video presentation today. And I've invited someone to stand in for you. And he'll be asking a few questions, and I'll be responding to them as if we were together. Today we're going to talk about your collection system and how we can manage it a little bit better.
Okay, that sounds great because it is out of control. We got so much going on.
That's not new. We've had a lot of people tell us they've got a lot on their plate. This graphic shows a funnel. It's a funnel of focus. We're going to come back to this, but I just want you to have this in mind, is that what we're bringing today is an idea of big picture down to little picture. So let me ask you, what is your current cycle of system maintenance for the sewer lines?
Well, we do emergency calls, obviously, are the top priority when those
course.
happen. And we try to assess a quarter of the system every year.
Okay. That sounds about the way things go for a lot of towns and cities, is where we see that a portion of the city is getting a lot of attention one year, and then another year another section of town gets attention, and they just work through the...
Yeah, and we have that one section with all the restaurants. We do that one every year.
That makes sense. So you have areas that you want to focus on, and those are known quantities, and you're like,
Yeah.
We're always going to hit those because we know they're going to have problems. And you may have, that corner of the park over there, you may have some roots that keep coming in from that big old oak tree or that, and that's one thing you want to maintain on a more frequent level. But in general, you're working towards this idea of dividing up the town into quadrants in your case, and working your way through each one of them a year at a time, just to make sure that things are working properly. Makes sense. That's the way most are doing it. So we select a neighborhood, we deploy some resources, and that allows us to feel more confident in our maintenance. We've identified some issues with the time-based protocol. One of them is we're cleaning every pipe segment regardless of condition. That just means we run the jet trucks and get them cleaned because we just want a clear knowledge that we've done it. Coupled with that is that we're just not looking at every pipe segment every year. We're looking at a fourth of it in your case, and we're working our way through town. And that's fine because those are the resource limitations that we have. Another thing that we've noticed is that pipe flow isn't necessarily quantified. It's either on or off, basically. We've cleaned it or we haven't. It's flowing or it isn't. And then the last thing is this idea of floaters. And floaters are the risks that are inherent in any system, and they happen at a moment's notice in odd places. And so we're not sure where they're going to happen, but they do. And if we're waiting for floaters to tell us where to go, it could be maybe 3-4 years out. So we've got this brewing problem that will come and bite us when we're least expecting it. It's because we're not looking at all the system all the time. So most cities are using this time-based protocol that we've just discussed, and we want to transition to this idea of a condition-based protocol. And RH Borden, if you can see on this picture right here, RH Borden wants to be that little blue arrow. We want to be that bridge from the time-based to the condition-based. But for condition-based to be effective, we need to have information about a condition of a pipe.
So what do you mean by condition-based?
Let me give you an example of a condition-based versus time-based. So time-based, back in the day when I started driving, I was told every 6 months to change my oil, which was good advice for the old car I was driving. That made the engine last a long time. But now I drive a newer car, and the car now has a sensor in it that says, change your oil now. That is information that is given to me by some piece of technology within that engine that says, do something. So that is a complete shift from this idea of time-based, meaning every 6 months I'm changing my oil, to now I'm waiting for a light or a sensor to tell me to do something. So that's the concept of condition-based. What that requires is information. And if we can get that information, then we can choose to change our activities. So there is now a sensor, a device that will help us understand when we need to perform a function. Introducing the SLRAT. SLRAT is an acronym for a Sewer Line Rapid Assessment Tool. It was developed back in 2008 in the city of Charlotte, North Carolina. Now, the public works people at Charlotte, North Carolina were overwhelmed by their collection system. They had SSOs right, left, up, and down. They were behind, and it got so bad that the EPA got involved. And the EPA says, time out, you got to do something. So they went to the University of North Carolina in Charlotte. They met a gentleman by the name of Ivan Howitt, an engineering professor of acoustics and electronics. And these two things together were a great fit for the problems they were facing. Ivan understood the circumstances they were under and developed this tool based on his knowledge and what they were dealing with. The tool is basically a device that measures blockages in sewer lines using transmissive acoustic technology. It was so successful that the EPA has written an extensive paper about it, how it works, its effectiveness, and it's being used by hundreds of utilities around the world and has ASTM standards and patents, and the veracity of the technology has been proven over time. The SLRAT is lightweight. It can go in backyards, it can go on back roads, it can go a number of different places that perhaps a cleaning truck couldn't go. In fact, I'll tell you a quick story. There was one city that had a series of manholes that were in a remote ravine, if you will, behind a number of houses that had no real access to it. Their concern was that sewer line was degrading and having troubles, but they didn't know. They said, we have no way of knowing what's going on there. With the SLRAT, we tromped through bushes and shrubs and pushed back branches and put this tool on the manhole, and we were able to evaluate that those pipes were actually doing quite well and avoided a $1.6 million road that the city was looking to build to get access to those. So now we have a tool that will help solve that in a lightweight
So how
fashion.
far apart can these manholes be?
The tool is limited to 800 feet, but we haven't found that to be an obstacle for us to overcome. The way they're used, as you can see with this slide, is that they're set up from manhole to manhole. There's a transmitter and a receiver that go on consecutive manholes, and they operate together. The transmitter sends out a signal, an audio signal. You can actually hear it. It's a series of tones that the receiver is listening for with a very sophisticated and specially tuned microphone. And that activity happens in about 80 seconds. And what the receiver is doing is it's listening for sound degradation. The sound degradation allows us to understand the flowability of the pipe and give us a score that's related directly to the amount of obstruction. And we basically leapfrog through a system, manhole to manhole, collecting this information as we go. Now, there's a little more to the SLRAT than just sound. There's a lot of technology built into those devices. Between each manhole, they're talking to one another with a radio, and they're able to sense the distance apart between each device. So that one's saying, hey, I'm 350 feet away, the other one's saying, yeah, you are. And so we now know the pipe length that we're getting based on the radios that are in the SLRAT. They're also GPS enabled. What this enables us to do is have a whole bunch of data come back at the end of the day. We get a timestamp, we get a date stamp. We also get the operator, and we get GPS data, and then last and most importantly, the flowability of the pipe. And all this is collected electronically, so we're not standing around with clipboards writing stuff down. That's all just built into the system. So I mentioned those scores. The scores come back, 10 being no obstruction at all the way down to 1, which means it's blocked. We've added color to those scores, so we get from red, yellow, green, and that allows us to easily quantify what we're looking at in a really short amount of time. The most interesting graph in this presentation today is the one that you're looking at right now, that pie chart. 72% of the pipes that the InfoSense SLRAT has assessed over its lifetime, which is over 100 million feet of pipe, is in good shape. And that begs the question, is 72% of our effort being wasted? Is 72% of the water being wasted? Is 72% of the fuel in our trucks being wasted? The answer, unfortunately, is probably yes. But the good news is that we now know there's 11% that needs to be addressed. And with the maps that are generated, we know where. And that is one of the great things about the SLRAT is the mapping capabilities of it. At the end of the day, we upload the data that's collected from the SLRAT tool into a secure website. And this secure website it's a database that quantifies all the activities that happen during the day. So we get all that information, the time, the date, the GPS location, and most importantly, the flowability of the pipe. All of that is collected, and then it can be exported into a map. This is an example of a map that's been created by the SLRAT, or the export data from the SLRAT. Based on the extensive training you've had today, where would you send your cleaning trucks?
Well, black has got to be bad, right?
That's right. The black is bad. The red's bad too.
Bad.
Yes.
So how bad is yellow?
Yellow's in that fair range. Our score's 4, 5, 6. We recommend cleaning when they get below 4, and we can sort this map and help you see where those are. But for sure, we want to focus on the red and the black. So that is where you would send your cleaning vehicles to get that work done. We probably wouldn't spend a lot of time on the yellows and green neighborhoods. Those might be newer parts of town. Those areas are flowing fine, and they may not need that attention today.
Okay, so I'm looking at a map like this, and our city has added 6 subdivisions. How's that going to work?
Sounds like you've got a lot of pressure to keep track of new growth. Well, that's one of the great things about the SLRAT is as we're collecting the data about the existing system, we can go and collect data for new parts of the system as well. And so we could be the beginning point, or the data from the SLRAT could be the beginning point. The great thing is it's real time, so you would have information about that new area of town, or those new subdivisions, and be able to decide, are we going to spend time with that or not? That's the great thing about data collection, is it can expand and grow probably a little faster than in other areas of the city.
So what's the difference between red and black?
So the difference between red and black is red had a little bit of sound coming through, and black means it's totally blocked.
Oh, okay.
Often is the case with a black is it's a belly. Okay. So back to the graphic we started out with in the beginning. The top line is number one, the SLRAT tool. We would screen the entire system, or as much of it as we could, with the SLRAT. And what we would find from that is that 70 to 90% of the assessed pipes would be flowing fine, just as the maps have shown us over time. Once we understand where the low-flowing pipes are, we would send in the cleaning trucks to take care of those areas, to pull out debris, and to make sure they're flowing well. As that activity happens, some things get revealed. Sometimes a little bit of root comes back with the cleaning, or sometimes extra soil comes back with the cleaning, and other problems get identified with the cleaning. With that information, we can send in the CCTV cameras to get a visual understanding of what's going on in that particular pipe. Once we have the CCTV videos, we can do more analysis and decide, do we want to really send in the engineering study or to bring in a tractor to relay a pipe or fix an offset joint or something of that nature. So to sum up the diagram of the funnel, the SLRAT gives us this quick overview of the entire system. From there, we go to cleaning the pipes, to the camera work, and then to the engineering that would address extensive problems. I've got so much more I can tell you. I'm grateful that we were able to meet virtually, and I would love to visit you in person. So please click on the link below, and I'll bring you out to lunch, and we'll discuss how we can help you further.